Friends, this question from QDB4 ST-Quiz2 December 1st 2024. This is the extension of the previous question. So how many prime paths are present in the given control flow graph? So for this question, first you have to draw the control flow graph. You first check with the previous question. Set of vertices and set of edges. From this we draw this control flow graph CFG. Many prime paths are present in the given control flow graph. They are asking prime paths. How many prime paths? That is the count of the prime paths. And this identify the set of test paths that covers the prime path coverage. That is PPC. Prime path coverage. The test path which covers the prime paths. So for this you have to find the prime paths. So what is the prime path? Prime path is the maximum length of the simple path. So simple path represented with SP. So for simple path has maximum length, that is the prime path. So first we have to find the prime paths by finding the simple paths. You find the simple paths after the maximum length of the simple path is a prime path. What is the condition for the simple path? No repetition. No repetition of the nodes except starting node and the ending node. That is, for example, 1, 2, 3, 4, 1 is a simple path. So because the starting node is 1 and the initial node is 1, this is allowed in a simple path. 1, 2, 4 is also a simple path. Repetition of the nodes are allowed. But 1, 2, 1, 4 is not a simple path. Is not a simple path because 1 is repeated at the intermediate nodes, not at the end node. So this is not a simple path. Simple path means no repetition except starting node and the ending node. No repetition of the nodes or vertices are allowed in a path. Control flow graph. We have to find the simple paths of length equals to 0. We start with length equal to 0. So what is the length equals to 0 means? Simple node. So this node has length 0, right? So that is all the vertices. 1, 2, 3, 4, 5 and 6. All these are vertices having the length equals to 0. That is, there is no edges, only vertices. Again the simple paths of length equals to 1. Simple paths of length equals to 1 means only one edge, right? Starting from node 1 there is only one edge, 1 to 2 and 1 to 3, right? There are two edges from 1. So that is 1, 2 is a simple path of length 1. That is 1, 1 here. 1, 2, 3. Starting from 1. And simple paths start at 2. Node 2 is 2, 3. That is 2 to 3, right? 2 to 3 is an edge. No other nodes starting from 2. Only we are checking outgoing edges from the each node. So that is outgoing edges from each node. 2 to 3. Starting from 3, 3 to 4, 3 to 4 and 3 to 6, right? 6 is ends with final vertex VF. Because of this we represented with exclamation mark for identify this path cannot be extended. The path that ends with final vertex VF, that is 6, is cannot be extended. That is represented with exclamation mark. Only starting from 3 is 2, right? Next node from node 4, 4 to 5, 4 to 5 and 4 to 6, that is also exclamation mark. 4 to 6 ends with VF, right? Okay. Only two edges. That is two simple paths of length 1 from starting from node 4. So next one is at node 5, only one, 5, 4. and node 6 there are no outgoing edges because it is the final vertex, right? So there are no simple paths starting with vertex 6. Next, simple paths of length equals to 2. That is, we extend this simple path length 1 to next node, it become length 2, right? So we extend 1 comma 2 to next node. So that is 1 to 2, 2 to 3 is a simple path of length 1, 1. 1 plus 1, 2, right? Total length 2. 1, 2, 3. Next 1, 2, 3 only starting from 1, 2. Next from 1, 3. So 1, 3, 1, 3, 4, right? 1, 3, 4 is in simple path of length 2. Next 1, 3, 6. 1, 3 and 6. This ends with exclamation mark because of 6, right? Termination with 6. This one 2 comma 3, we extend 2 comma 3 to next node. 2, 3, 4, right? 2, 3, 4. And next one is 2, 3, 2, 3, 6. 6 is also a terminal node. Next 3 comma 4 starting from 3. So that is 3, 4, 6. 3, 4, 6 and 3, 4, 5. Simple path of length 2. 3, 4, 5. Starting from 4, that is we extend. We cannot extend 3 comma 6. We cannot extend because it ends with exclamation mark, right? Because of that we cannot extend this simple paths, we cannot extend. Next 4 comma 5. So that is 4, 5, 4, 5, 4 is also a simple path and it is a loop represented with star because this is also a simple path, right? 4, 5, 4. Starting vertex is V0 is 4, VF final vertex is 4. This is a load, this is a valid simple path. So this is a simple path which is a load. Only with 4 this one. No other nodes are possible because there is a loop, right? Next we extend simple path of length 1, 5 comma 4 to next node, that is 5, 4, 5. This is also a loop and this is also a simple path and a load. Next 5, 4 and 6, right? It cannot be extended, exclamation mark and with as of length equals to 3. So we extend all this one, okay? We extend this 1, 2, 3, this path. So that is simple path of length 2, 1, 2, 3 to next node. 1, 2, 3, that is 1, 2, 1, 2, 2, 2, 2, 3 and 3 to 4, right? 3 to 4 and 1, 2, 3 and 6 also possible. 1, 2, 3, 6 and it cannot be extended. 6 is VF. Only 2 are possible. Next we extend this one 1, 3, 4. That is 1, 3, 4, 4, 5. This is one simple path of length 3. So next 1, 3, 4, 4, 6, right? 6. This is exclamation mark and with. So these are only possible for this 1, 3, 4. Next 1, 3, 6 cannot be extended because it is a it cannot be extended, exclamation mark, right? These simple paths with exclamation mark, this one and star are cannot be extended. So 2, 3, 4. You can extend 2, 3, 4 to next node. 2, 3, 4, 4, 5, right? 4, 5. This is length 3. So this node 2 to 3 is length 1. 3 to 4 is length 1. 4 to 5 is length 1. Total length equals to 3, right? Plus 3. Okay. Next extend 2, 3, 4, 6 also. 6, 3, 4, 5 and 4. It's not a simple path. 4 is repeated. So only these are the simple paths and cannot be extended. No simple path with 3, 4, 5. 3, 4, 5. So if we consider as a 3, 4, 5. So like this 3, 4, 5. 5 to 4, right? 5 to 4. 4 is repeated and is not intermediate node also, not at V0 and Vf. So this is not a simple path. We don't consider it as a simple path. Equals to 4. Okay, length equals to 4. So this cannot be extended. This green color underlined R cannot be extended. 2, 3 cannot be extended because these 3 are ends with exclamation mark, right? Cannot be extended. So 1, 2, 3, 4. So that is 1, 2, 3, 4. We extend this one. 1, 2, 3, 4. 2, 3, 4, 5. This is a simple path of length 4. Next 1, 2, 3, 4. 4 to 6, right? So that is 1, 2, 3, 4, 6. Next we extend this one. 1, 3, 4, 5. 1, 3, 4, 5. 4 again loop is formed. It cannot be extended. Okay. 2, 3, 4, 5. 2, 3, 4, 5. Again we 4 to 5 is a loop, right? If we reach 5, again we are going to the back. We are going back to the node 4. So it's not a simple path. See, for example, if we extend this one, 2, 3, 4, 5, 4, 5, again 4, right? Again 4. So 4 is repeated at the intermediate nodes, right? This is not a simple path. So this is not a simple path. Only repetition of nodes allowed at starting node and initial node. So these are not only simple paths of length are length equal to 4 are only 2 simple paths. Length equal to 5 is not possible. All these are simple paths of length 0, 1, 2, 3 and 4. So from this we want to identify the length of the simple paths. Identify the prime paths. Prime paths are simple paths of maximum length. So we starting from length 4. From length equals to 4, these two are prime paths. Okay, that is first prime path is first one. 1, 2, 3, 4, 5. And second prime path is 1, 2, 3, 4, 6. These two are prime paths. Prime paths. Okay, so first one is 1, 2, 3, 4. So 1, 2, 3, 4 here, right? So this is not a prime path. 1, 2, 3, 6. 1, 2, 3, 6 is not there. So this is a prime path. So the third prime path is 1, 2, 3 and 6. Next this one 1, 3, 4, 5, right? So it's not covered anywhere. This is also a prime path. So 4 prime path is 1, 3, 4 and 5. Fourth one. Next fifth one. So 1, 3, 4, 6 is also a prime path because it is not covered anywhere. So 1, 3, 4, 6 is a prime path. Next 2, 3, 4, 5. 2, 3, 4, 5. This one. 2, 3, 4, 5 is here, right? It's not a prime path. 2, 3, 4, 6 here, right? So it's not a prime path. Next we check with simple paths of length equals to 2. Next 1, 2, 3. So this one simple path of length, yellow color one. So 1, 2, 3 is covered here, right? In length equals to 3 is covered. Is not a simple path. 1, 3, 4. 1, 3, 4. is covered here. It's not a simple path. 136. 136 is a prime path. Sorry, I am telling. So first one is 1, 2, 3 is a simple path of length 2 is covered in length 3, right? It's not a prime path. So next one is 1, 3, 4 is a simple path of length 2. 1, 3, 4 is covered here. 1, 3, 4 is covered here, so it's not a prime path. Next prime path, friends, 1, 3, 6, this black color one. 1, 3, 6 is not covered anywhere. Length equals to 2 simple path. 1, 3, 6 is a prime path. So prime path 3, 6 is a prime path. So next 2, 3, 4. 2, 3, 4 simple path length equal to 2, 3, 4 is covered here, right? Length equal to 3. It's not a prime path. And 2, 3, 6. 2, 3, 6 is covered here, right? It's not a prime path. And 3, 4, 6. 3, 4, 6. This simple path is covered here. 3, 4, 6 is not a prime path. And 3, 4, 5. 3, 4, 5 is covered here. So it's not a prime path. It's not a, this one is prime, not a prime path. So next 4, 5, 4 is not covered any simple path of length equal to 2, 4, 5, 4. 4, 5, 4, that is a loop. It is a prime path because it is not covered anywhere, is a prime path. So this is also a loop. This is also a prime path. 5, 4, 5 is a prime path, is not covered anywhere. Next 5, 4, 6. 5, 4, 6 is also a prime path, is not covered anywhere. So ninth one is 5, 4, 6 is also a prime path because these prime paths are not covered in the this prime path. Length equals to 4. So this length equal to 3 prime paths covered by length equal to 4. The length equal to 3 simple paths are covered by length equal to 4 simple paths. These are not prime paths. Simple path of length equal to 1, 2 is here, right? Simple path of length equal to 1 we are checking in length equal to 2. Maximum length. It is here, right? Length equal to 2. It's not a prime path. So 1, 3 is also here, right? It's not a prime path. 2, 3. 2, 3 is here, right? It's not a prime path. 3, 4. 3, 4 here, right? It's not a prime path. 3, 6. So 3, 6 here, right? Here also it's not a prime path. 4, 5. 4, 5 here, right? It's not a prime path. 4, 6. 4, 6 is here, right? It's not a prime path. And 5, 4 is here. It's not a prime path. So all these are length equals to 0 is covered in all the prime paths, right? 1, 2 single nodes. So these are not prime paths. These are not prime paths. So the answer for this question is total there are 9 prime paths. Total these are 9 prime paths. That is minimum number of prime paths are 9. So answer for this question is this one. Next question is whether test path that provides the prime path coverage. That is the test path. So this is in the options. This is the test path 1. This is the test path 2. So this test path 1 and test path 2 it covers all the prime paths. So this is a prime path coverage. So all these are 9 prime paths covered by the all these test paths. Okay. So we will check with first one. 1, 2, 3. This one 1, 2, 3, 4, 5, right? So in this option 1, 2, 3, 4, 5 is there, right? So 1 is covered. So next 1, 2, 3, 4, 6. So this one, right? 1 2 3 4 6 prime path 2 is covered. Next 1 2 3 6. So 1 2 3 6, this one prime path 3. Next 1 3 4 5. Next fourth one 1 3 4 5 here, right? 1 3 4 5, this is prime path 4. So next 5 1 is 1 3 4 6, 1 3 4 6. So this one, right? 1 3 4 6, this is prime path 5. Sorry, this previous one prime path 4. So next 6 1 3 6 is a prime path. So this one, right? 1 3 6 prime path 6. Next 5 5 4 5 4 5 4, we will check. These three are loops, right? This one 5 4 5 and 4 5 4 also covered, that is 7 and 8 also covered. One prime path is left, 5 4 6. So 5 4 6 is here, right? So prime path 9 is there. Here also 5 4 6, 9 is also covered. So this option is correct. So we will check which options are not covered by these other options also. So in other options 9 is covered, 5 4 6 is there. Here also 5 4 6. So in this option C, 9 is covered. Next 1 2 3 4 5 4 6, same, this is similar, right? 1 is covered. Next 2 is covered, this one. Next 1 3 6, 6 is covered, 6 is covered. Next, so loops are covered, right? 5 4 5 4 5 4 5 4 5, 7 and 8 are covered. 7 and 8 also covered by this option C. So 5 is 1 3 4 6. So 5 is not covered. So for this option C, 5 prime path 5 is not covered. And next 6 1 3 6 covered. 4 1 3 4 5. So 1 3 4 5, 4 is covered. 9 5 4 6, 5 4 6 also covered. Only one test path 5 is not covered. 1 3 4 6 is not there. So because of that, option C 1 3 4 6, this prime path is not covered. Prime path. Because of that, this option is incorrect. In the option B, same 1 3 4 6 5 prime path is also not covered. These prime paths are not covered. 1 2 3 4 5, okay. 5 4 6 is there. 9 is also covered. 2 is not covered. 2 is not covered. 1 2 3 4 6 is not there. In option B, 1 3 6 is covered. 3 is 1 2 3 6. Prime path 3 is also not covered. 5 is 1 3 4 6. 5 is also mentioned, right? 6 is covered. 4 1 3 4 7 8 9 are covered. So these three prime paths are not covered by option B. Option A, so 1 and 9 are covered. 2 is not covered. 3 is also not covered. 5 is not covered. And 6 is also not covered. Rest all are covered. So because of this, it does not cover all the prime paths. So option D only covers all the prime paths. Friends, if you like my videos, please like and subscribe my channel, and thank you for watching.